Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. This is Exploration. Every week in Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, we're going to summarize some of the big stories in science. Well, if you've been following the headlines, you know that some of the biggest stories on the planet Earth now revolve around the environment and science. Leading off, we're going to talk about the South Pole. Did you know that a huge chunk of Antarctica broke off just a few days ago? A piece that weighs 1 trillion tons, that's trillion with a T, a piece of ice the size of Delaware broke off. And the question is, what does it mean for sea level? What does it mean for our mode of existence? And gradually, the stability of the South Pole is put into question. So we'll talk about that. How stable is the South Pole anyway, given the fact that if the entire South Pole were to melt, and of course that is absolutely the worst case scenario, sea levels would rise about 200 feet. And then we'll say a few things about the 6th extinction cycle. Professors at Stanford University did a census of the species of life on the planet Earth, and they came up with the fact that we are now entering the 6th extinction. Of course, the trilobites and the dinosaurs were wiped out in previous extinction cycles, but hey, another asteroid has hit the Earth. This new asteroid is called Homo sapiens. Yes, you and me. Human activity is beginning to wipe out species on the planet Earth. Did you know that as far as West African lions are concerned, there are only 400 left? That's right, only 400 of them left. And cheetahs, the population of cheetahs is only 7,000, and their population has been declining by about 50% just within the last 15 to 20 years. In the future, perhaps the only way you will be able to see a lion is in a zoo. And of course, the food chain is being affected by this mass extinction cycle. Who's at the top of the food chain? We are. And it wouldn't take much to dislodge us from being at the top of the food chain. So it's not just penguins and lions and tigers that we're talking about. We're talking about you and me. And speaking about health, the Food and Drug Administration is about to give approval for a new form of cancer therapy. It turns out that gene therapy is now possible as a cure for certain forms of cancer, like one form of leukemia. Instead of radiation, that is zapping cancer cells, instead of surgery, that is slicing and dicing cancer cells, instead of chemotherapy, in terms of poisoning cancer cells, why not simply reprogram cancer cells, hack into the genetic code of cancer so that it becomes benign? And that's the promise that's being offered. However, there are side effects to this, and we'll talk about that as well. Well, let's just jump right into some of the big stories in science and politics. The lead story today, perhaps on every newspaper on the planet Earth, is the fact that the South Pole is beginning to crack. A huge piece of the South Pole, the size of the state of Delaware, just broke off a few days ago. It is so big that it will actually endanger sea lanes and shipping lanes. And the question is, well, what does it mean? What caused it? And what does it mean for us? First of all, it is a tremendously large chunk of ice, 1 trillion tons of ice. It is 2,500 square miles in area, a little bit bigger than the state of Delaware. And the question is, what caused it? Well, first of all, the Larsen Ice Shelf C broke off, but previously Larsen Ice Shelf A and Larsen Ice Shelf B also broke off. Why? We think because of global warming. In the case of Larsen A and B, we see the fingerprint of global warming. With Larsen C, however, it's not quite so clear. There's still some debate among climatologists as to exactly how much climate change is responsible for the instability of Larsen C. However, we have to take a look at the big picture. And the big picture now is that the stability of the South Pole, which was once thought to be a given, that it would be stable for centuries, is now being called into question. Something that I didn't think would happen in my lifetime, or the lifetime of many climatologists, is happening now. For example, if West Antarctica were to break up and melt, of course we don't expect that to happen anytime soon, but if West Antarctica were to melt, sea levels around the planet Earth would rise about 10 feet. Now, if the entire South Pole were to melt, and we don't expect that to happen anytime soon, sea levels would rise about 200 feet. And just remember that for every vertical foot that the sea level rises, you lose about 100 times that horizontally in terms of beachfront properties. So as sea levels begin to rise, you can realize that we're going to be losing a tremendous amount of beachfront property. Not only that, but realize that 50% of the population of the United States lives in the proximity of the coasts. And so we're talking about a major destabilization taking place if this cracking of the South Pole accelerates and causes sea level rise. Now, let's be clear about this. Larsen Ice Shelf is floating on water. I repeat, Larsen Sea, which is now, of course, broken off, is floating on water. So therefore, we do not expect sea levels to rise as a consequence of this latest crack. I repeat, we do not expect sea levels to rise because of the breakup of Larsen Sea, because Larsen Sea was already floating on water. But what's behind Larsen Sea? What's behind Larsen Sea are the ice sheets, which sit on land. And that's the killer question. In other words, Larsen Sea is a buffer that prevents ice sheets from behind sliding into the oceans, and that would definitely raise sea levels. So in other words, the immediate breakup of Larsen Sea will not raise sea level rise. However, the instability caused by this could eventually lead to the sliding of ice sheets into the ocean, and the ice sheets sit on land, and if they go into the oceans, it would definitely raise the sea levels. And so you see that the Larsen Ice Shelf was a buffer that created stability in the South Pole. But Larsen A has broken off, Larsen B has broken off, and now an even bigger chunk, not just the size of Rhode Island, but the size of Delaware, Larsen C has now broken off. Now, the other question is, well, why should you care? I mean, penguins? Are we going to be worried about the livelihood of penguins? Well, you see, the stability of the South Pole is in danger. Several years ago, a climatologist questioned the stability of the South Pole and said that that's something that we now have to study. Before, we never studied it, he said, because, of course, the South Pole is quite stable. Well, that article was prophetic, because now climatologists are beginning to think the unthinkable, and that is the stability of the South Pole. Now, the North Pole's instability is well documented. We know that the ice cover of the North Polar region has decreased by 50% over the last 50 years. And we know that because submarines regularly visit the North Pole. But the South Pole, we don't visit the South Pole that often, but now we have satellites and advanced telemetry that allow us to measure the recession of these ice shelves. And the numbers are not encouraging at all. And so once again, to repeat, we're not saying that sea levels are going to rise immediately. But it does mean that there's simply so much fresh water locked into the South Pole that we have to look at cracks. Also, just a few years ago, it was discovered quite by accident that there are underground rivers underneath the ice sheets. We didn't know that before. And so, in other words, even if a satellite photograph seems to indicate stability in the ice sheets, in the ice shelves, there's more lurking under the ice cover. And we find underground rivers of melted water that flow underneath the ice sheets. And so we have to realize that the stability of the Antarctica, which we once thought to be a given, is now being called into question.
Also, talking about the environment, professors at Stanford University recently did a study of the populations of mammals and vertebrates, and they found some rather startling results. They analyzed 27,600 types of vertebrates today, animals which have a backbone. And they found something startling, that they found that 30% of them are in decline. 30%. So they also found that if you look at mammals, which is, of course, a subset of vertebrates, they found that 40% of them are in decline. In fact, they concluded that 2 vertebrate species go extinct every year. Let me repeat that. Every year, there are 2 vertebrate species that go extinct. And that's only the ones that we know about. There could be hundreds that we don't even know about because we haven't ventured into the Amazon and places where other species may exist. And so the professors at Stanford said we are witnessing the 6th extinction cycle. Now, we know that 65 million years ago, something plowed into the Yucatan of Mexico, perhaps wiping out the dinosaurs. That was the 5th extinction. And even before that, we had trilobites. Trilobites that proliferated the oceans. They also went extinct. In fact, because of that, it paved the way for the rise of the dinosaurs. Now, these professors at Stanford are saying that we are witnessing the 6th extinction cycle. A new comet or asteroid has hit the Earth, causing this massive extinction. What is the name of this asteroid? It's Homo sapiens. That's right, you and me. Because of economic development, because we are paving the forests, because we're beginning to change the ecology of the planet and destroying the breeding grounds of many species, we're witnessing a human-generated extinction cycle. Now, it's worse than you think, because certain species are more important for the food chain than other species. Take a look at the honeybee. The honeybee, of course, gives us pollination, and if the honeybees go extinct one day, then a whole series of flowering planets may also go extinct. And, of course, we rely upon the honeybee for sugar and for honey. Not to mention elephants. Elephants, believe it or not, are an integral part of the food chain. First of all, they disperse seeds. They're very important for the dispersing of seeds because elephants can consume vegetables and fruits, and when they defecate, that spreads seeds. Not only that, but they cut paths. They cut paths in the forest which are useful for other species to follow. So in other words, if one important species goes extinct, then there could be a chain reaction. All the other species which depend upon that species could also go extinct. And again, you may say, well, why should I care? The South Pole, nothing but a bunch of penguins. The Amazon, nothing but a bunch of spiders. Why should I care? Well, you see, we are at the top of the food chain. Think of the food chain. We're at the very top. We're the top predator. And it wouldn't take much to dislodge us from being at the top of the food chain. Let me give you an example. For example, how many grains do we consume? Well, believe it or not, we only consume about 5 different grains, like wheat and rice. If any of these grains were to be wiped out because of a blight or something like that, our food supply would be affected as a consequence. And so again, it wouldn't take much to dislodge us from being at the top of the food chain. And that's why we should care that another asteroid has hit the Earth. It's called asteroid Homo sapiens, and it is driving the 6th extinction cycle. And the question is, will we be the victim of our own extinction cycle? In other words, when these cycles occur, certain vulnerable animals disappear immediately, and at the very end, the most hardy animals begin to disappear. So the irony is, if we set into motion the 6th extinction cycle, then perhaps the last species to go extinct would be Homo sapiens. And speaking about life, there's good news coming from the FDA. There's a new cancer therapy that's being looked at very seriously, And the FDA, according to the betting, will probably approve it. So let me explain. So far, for cancer, we have three ways of approaching cancer. We have radiation, which can zap it, surgery, which can slice and dice it, and chemotherapy, which can poison it. Of course, everybody knows the side effects, which are horrendous. With radiation, your hair falls out, you experience nausea, very unpleasant. With surgery, many parts of the body which are healthy also have to be cut out as a consequence. For example, when you have breast surgery, there's a debate as to exactly how much of your own breast has to be sliced out. And then with chemotherapy, you have to literally poison yourself, because to poison cancer cells, you also have to poison healthy cells as a consequence. So all three have horrendous after effects. But here's a new one, a new treatment that's coming out that some people think could be like a magic bullet. And that is gene therapy, actually changing the genetic makeup of your own cells. First of all, what is cancer? That was a mystery for many, many centuries, but we now know what cancer is. It's a disease of the genes. It turns out that if you have 4 major mutations in your genes, then you could come down with cancer. And it turns out, therefore, that that is a unified theory that links all the theories of cancer. For example, some people think it's caused by chemicals, by the environment, by pollution, by radiation, by the food that we eat, by smoking. Well, the answer, of course, is all of the above. But how? How do all these things affect cancer? They affect our cells by causing mutations. In fact, we can now calculate for every cigarette you smoke, we can calculate how many hundreds of mutations are created in your cells. When 4 major mutations occur in your cells, it becomes cancerous and it may eventually kill you. Well, here's how this new therapy works. First of all, you take some of the T cells of your own body. The T cells of your body are your line of defense, is part of your immune system. Now, we know that HIV, for example, is deadly precisely because it attacks your immune system, leaving you vulnerable for everything else. Well, what you can do is you can actually take the HIV cells, which are good at attacking your T cells, modifying them, making sure that they are no longer dangerous, and empowering them to insert a gene into your cells, which allow your cells to recognize the cancer cells. And so in other words, you take white blood cells from your blood, change them, and reinsert them back into your blood. Now, believe it or not, the human body can actually recognize certain forms of cancer. In fact, you get cancer all the time, but your body identifies it and kills it. However, sometimes cancer cells are devious. They begin to create a protein coat surrounding themselves that makes them invisible to your T cells. And so it's like a cloaking device. In other words, your cells naturally, your T cells naturally will attack cancer. But cancer is not static. It can eventually create a protein coat that makes them invisible to your T cells. So here's the logic. Why not modify the T cells of your body so that they can recognize cancers? And that's what this genetic mutation does. Now, what's the side effect? Of course, there are always complications. There's always a catch to everything. First of all, cost. The cost of this, roughly, we don't know exactly how much it's going to cost, but the complete therapy could cost on the order of $300,000. But don't faint immediately, because, of course, prices will eventually go down. Novartis, which manufactured this therapy against certain forms of leukemia, they have to get a return on their investment, or else they'll go bankrupt. And we don't want them to go bankrupt. They have to make back the money that was spent developing this therapy. Second of all, there are health side effects as well. One young girl, for example, experienced extreme lung congestion, a tremendous fever, until the fever broke and she was practically cured of this fatal forms of cancer. In fact, of the patients that have been tested, 63 patients, 82% of these cancers went into remission. And you have to realize that these 63 patients were not ordinary patients. They were terminally ill. Science had pretty much given up on these 63 individuals. And what happened was 82% of them, in some sense, came back from the dead. These were the walking dead. These were the people that scientists had given up hope on, and yet 82% of them had their cancers go into remission. In fact, the therapy is so effective that each energized and modified T cell can kill up to 100,000 cancer cells. Well, we're going to, of course, track this therapy because, of course, as time goes by, we may find other side effects. However, the FDA is expected to approve this therapy, and this therapy is so general, it can attack not just leukemia, but brain tumors and many other forms of cancers as well. So we'll keep track of it, but you may want to take a note of it, and that is gene therapy may finally be coming of age. After decades, in fact, of hype and hope of fixing broken genes, we now may be at the beginning of being able to cure certain forms of cancer which are commonly thought to be incurable. Also in the news, we should mention the eclipse of August 21st, 2007. The last time we had a total eclipse of the sun that cut right through the United States is 40 years ago. So if you missed your chance decades ago, here's your chance to watch a total eclipse of the sun on August 21st. As I mentioned, it'll cut right through the U.S. of A. We should also mention that even if you are not in the direct path of the shadow of the moon, you will also be able to see a partial eclipse if you live in the U.S. of A. We should also point out that if you missed this one, there's another one coming too in 2024, a second chance to see a total eclipse of the sun. First of all, what's the difference between a lunar eclipse and a solar eclipse? A lunar eclipse takes place when the moon goes into the shadow of the Earth. This happens rather frequently, once every few months in fact. The moon turns blood red, quite a dramatic sight. The moon turns red in the night sky when the moon moves into the shadow of the planet Earth. However, a solar eclipse is much rarer. And a solar eclipse happens when the Earth goes into the shadow of the moon. So in other words, the moon is between the sun and the Earth. Now, by an astronomical coincidence, it turns out that it's a coincidence that the moon just blocks out the sunlight from the sun. So it is perfect. We see the sun in all its glory without the disk itself when the sun is eclipsed by the moon. And also we have to say a few things about safety. There's a legend, which is probably incorrect, but there's a legend that Galileo looked at the sun directly during an eclipse or during one of his observations and burned the retina of his eye. And we do know that in his 70s he actually did go blind in one eye. However, most historians believe it was a cataract and not caused by looking at the sun. But a word to the wise, even with sunglasses, even with a darkened film, it's not enough to wipe out the excess sunlight. You could still have an injury to the eye if you look at the sun via sunglasses or with a darkened piece of film. The best way to look at the sun during a solar eclipse is not with a telescope or binoculars. That's perhaps the worst way, but using a pinhole camera. That is, you take two sheets of paper. On the first sheet of paper, you get a pinhole, and then you look at the image cast by the pinhole on the second sheet of paper, and you can very clearly see the outline of the sun during the solar eclipse. Or you can use a colander. A colander, of course, has many holes in it, and so with a colander you can actually see many images of the eclipsed sun. Another way to do it, if you want to use glasses of some sort, is to go to your public library. Many public libraries for free are giving away eclipse sunglasses. These sunglasses, in fact, are dark enough so that you're not going to injure your eye. We should also point out that eclipses are important for scientific and also historical reasons. By looking at ancient manuscripts and ancient cuneiform documents, you can actually date when they were written. This is amazing. We can actually date these ancient documents because they record the position of the planets and the eclipse, allowing scientists to recreate the historical conditions. And we found out that many of the earliest eclipses on record go back 3,000 years into the past. It's amazing. 3,000-year-old documents show that humans were interested in the heavens even back then. And we can date these documents because they record certain eclipses and the motions of the planets on the ecliptic plane. We should also mention that the Greeks in about 200 BC or even earlier were able to calculate the size of the Earth, to calculate the distance to the moon and the sun using the power of mathematics, trigonometry, and eclipses. And so the ancients were not stupid. They were able to calculate the rough dimensions of parts of the solar system using eclipses. And of course, there's also the famous eclipse of 1919, which was observed by a party of scientists wanting to prove Einstein's theory of general relativity. Einstein predicted that light should bend as it goes around the sun, but you can't do that because the sun, of course, is quite bright. But during an eclipse of the sun, you can see the background stars behind the sun, even in daytime. And then you take a picture of the sky with the sun, showing the stars, and a picture of the sky without the sun at night. And then you compare the two pictures, and bingo, you see that starlight has actually shifted as a consequence of light going around the sun. So the exact positions of the stars has changed because of the presence of the sun. Using this data in 1919, scientists were able to show that, by golly, Albert Einstein was right, that sunlight does in fact bend as it goes around the sun. In fact, we use it today because the light as it goes around the sun creates a ring. These are called Einstein's rings. And we see Einstein's rings by analyzing distant galaxies now. And so, yes, an observation done in 1919 not only proved that Einstein was right, but it's also a method used even today to look at objects that are very, very far away and to calculate their properties. And that concludes the first part of Exploration. Stay tuned for the second part when we rebroadcast a very important interview with Peter Ward, which is very germane to today's discussion because we're talking about the breakup of the South Pole. Our special guest today is Peter Ward, author of the book Flooded Earth. So what does it mean if one day the Antarctic becomes unstable? What does it mean if we have a flooded Earth and sea levels begin to rise, changing the ecology of the entire planet? What happens to humans? And so once again, our special guest today, it's a rerun of an interview we conducted before with Peter Ward, author of the book Flooded Earth. Welcome. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is the second half of Exploration. In the first half of Exploration, we summarized some of the big stories in science, including the breakup of the South Pole. That is, a chunk of Larsen Ice Shelf C, the size of the state of Delaware, weighing 1 trillion tons, has just broken off the South Pole. And what does it mean? What does it mean for the stability of the South Pole, which in turn controls a good chunk of the weather and contains a good chunk of the entire freshwater content of the planet Earth? As we mentioned, if West Antarctica were to one day completely melt, sea levels would rise about 10 feet. However, if the entire South Pole were to melt, sea levels would rise a staggering 200 feet. And so what does it mean if we have a flooded Earth? So we're going to rebroadcast a previous interview we conducted with Peter Ward, author of the book Flooded Earth, because of the fact that we're now witnessing perhaps the gradual breakup of parts of the South Pole. Realize that the temperature of the South Pole and the North Pole have been heating up faster than the rest of the Earth, and of course this is due to global warming. Already Larsen Ice Shelf A broke off, Larsen Ice Shelf B broke off, both of them linked to global warming. There's still some debate among climatologists as to how much human activity contributed to the breakup of Larsen Ice Shelf C, but the point is that the Larsen Ice Shelf C was a buffer that prevented the ice sheets from sliding into the oceans, and that would definitely raise sea levels on the planet Earth. And so with this, once again, is a rebroadcast of a previous interview with Peter Ward, author of the book Flooded Earth. And now I'd like to introduce our special guest for today. He's Professor Peter Ward. He's a professor of biology and earth and space science at the University of Washington in Seattle. The book is rather disturbing and is hitting the bookshelves this week. The book is called The Flooded Earth, Our Future in a World Without Ice Caps. Now, on exploration, of course, we've had programs about global warming. We've talked about the effect on population and on agriculture and on tropical diseases. But here's a book that talks specifically about how our cities, some of our major cities, will go underwater or may have to be abandoned because of global warming. The book is controversial. However, it gives you a frame of reference as to what scientists are thinking if sea levels continue to rise, not 1 foot, 2 foot, but 5, 6, 7, 8 feet above normal. What happens to our great cities? What about warfare between nations when national borders begin to collapse because of mass migrations of hundreds of millions of people? Something to think about. Once again, the book is called The Flooded Earth.
Much more fun project I've been in, Rare Earth with Don Brownlee. I'd rather do astrobiology.
Oh. Well, I actually interviewed you, either you or Brownlee, I forgot.
Yeah, you did. And it just seems to be a happier topic to me to put my head in the sand. But unfortunately, I don't think we can do that much more.
Yeah, I don't think so either. Okay, well, the engineer gave us the go-ahead, so let's start with the first question. Oh, the first question that we always ask our guests is, how did you, as a youth now, get interested in science? So I'll lead off with that question. So, dig back to the cobwebs and think about what it was as a child that set you off in the direction of science. Okay, so the engineer said we're going to start in 10 seconds with that first question about you as a youth. Professor Ward, you're a professor of biology and earth and space science at the University of Washington in Seattle. However, as a youth, what steered you in the direction of science?
Well, thanks so much for having me. And I think scientists know from an early age that they're going to be scientists, so it was indeed youth. What got me going were dinosaurs. My mother and father were from New York. I grew up in Seattle. We didn't have a single dinosaur skeleton, and so I was given this guilt treatment that I had to be in Seattle, and it's my fault or something that there were no dinosaur skeletons. But that got me going.
Okay, and that set you off. And how did you get interested in astronomy and earth and space science?
Well, I certainly started in paleontology, so I was looking at my feet all the time down at the ground. But it became evident, I think, in the first part of this century, or really the end of the 20th century, that there was a great deal to learn about life in space and especially how other Earth could be constructed from what we knew in our own Earth history. And so deep Earth history can inform us about astrobiology, and in the book I've just done now, it is deep Earth history which can inform us about what climate change is capable of.
Okay, well, the book is called The Flooded Earth, Our Future in a World Without Ice Caps. So let's start with the ice caps. The North Polar region over the past 50 years, since submarines have visited the North Pole, seems to have decreased by 50% just in the last 50 years. So what is your projection of the North Pole and also Greenland going into the future?
Well, the great dream of the Europeans coming to North America was for the Northwest Passage. I mean, this was a driving impulse to try to find a quick trade route to China. We're going to have that. But what I really didn't understand thoroughly enough was the difference between an ice cap and an ice sheet. All of the North Polar ice cap can melt away, and it will have no effect, essentially, on sea level. It is the ice on land, the ice sheets, which are the biggest of which, of course, are Greenland and in Antarctica. Anything that melts on those goes directly into the ocean and raises the level of it. And the biggest, scariest scenario is equivalent to what we call an ice sheet collapse. So imagine you have a cup of really warm water and then dump in about 10 or 15 ice cubes, and up goes the level of that water really fast. Well, that is the scenario for an ice sheet collapse in Antarctica.
Okay, well, we've heard about what's happening in the North Polar region, but in the South Pole, we have huge chunks of ice breaking off. But what does that mean, given the fact that most of the South Pole seems stable, at least temporarily?
You know, I've come back from 2 separate trips to Antarctica over the last 2 years, and we're looking at deep time events of the climate down there, but you can't help but notice what's going on all around you. It was melting like crazy. When you have both kinds of ice down there, you've got floating ice, which, again, if that melts, doesn't matter. But you've also got all this ice on land. When it melts, the water goes down to the ice rock contact, of course, and that acts as a lubricant. So when you have really anomalous warming, stuff that is on the edge of this can calve off into the ocean. That causes great global change in terms of sea level rise.
Okay, and talking about sea level rise, doesn't the heating of the Earth itself cause expansion of warm water, which causes the sea level to rise? Just the sheer fact that the Earth is warming up.
It sure does. And matter of fact, if we stopped all emissions right now, we just went completely emission neutral, the ocean is still going to rise in its level because of thermal expansion. There's been so much warming already that the ocean has a lag effect, but over the next 40, 50 years, we could expect nearly a 3-foot sea level rise if, based on the temperatures that we have now and the continued warming. Just from the thermal expansion, no ice at all.
Okay, 3-foot rise without any ice. And I guess for every 1 foot vertical that you lose, how much horizontal seacoast do you lose?
Well, the seacoast itself is affected more strongly by storm surge. And you can think of storm surge as equivalent to going off a diving board. You jump off a diving board at a given height, but if you bounce a couple of times, you go way higher. It's as if you have a launching platform as sea level rises. The storm surge, which are the nasty big waves that rise higher than normal sea level, can hit coasts. But the sideways movement of the ocean is far more serious in terms of what its salt does. Salt goes laterally quite easily, and depending on the type of soil, it is the salinization of the sea level crops that I think is the greatest single danger from sea level rise. It's stunning how much of the world's productivity, and especially the rice regions in Southeast Asia, are on deltas. A delta is built out from a river hitting a calm ocean. If you have a 3-foot sea level rise, every delta on this planet will disappear. We're talking about the Nile, the Brahmaputra, the Mekong, and these are all enormously productive areas. So this is the big blow that is coming. The equation is we're going to have a rise in sea level at the same time we have a rise in human population. As you know, we're at 6.6 billion now, but we're heading towards 9 billion. And this, too, is built into the system. It's kind of like the warmth of the ocean. We could do tremendous birth control efforts now, but we're probably still going to hit that 9 billion. So the intersection of 9 billion with reduced agricultural yields because of the sea level rise is the scariest aspect.
Okay, well, let's assume that we do nothing. That is, we simply treat everything as normal. We keep on spewing carbon dioxide into the atmosphere. Let's take the world 2050. In 2050, what will coastal cities like Boston, New York, Miami, Los Angeles, San Francisco, Seattle, what will they look like if we just keep spewing carbon dioxide in the air as if there was nothing wrong, and we project 50 years into the future?
Well, 2050 is still not going to be apparent that we're in a crisis. It's kind of like watching a speed car as it leaves the Indy 500. If you catch it in the first 10 feet or so, it's not going very fast. But acceleration is an interesting thing. It will be apparent to all city planners in 2050 that something new is going on, and they won't like it. Much of city infrastructure is now buried. People put down, obviously, all the sewage, but now so much of the electrical and advanced communication systems are underground. They were not engineered for salt water. They were engineered for fresh water. Bringing a lot of salt into city infrastructure is going to be a huge headache. It's also going to be a headache for trying to keep freshwater reservoirs going and freshwater aquifers. So 2050 is the time when the alarm bells are going to be ringing. The populace isn't going to see much. It might only be a foot rise by then, but certainly there will be urban red lights going off like crazy.
Well, in New York City, a few years ago, we had a gigantic nor'easter which sent a surge of water into Manhattan, which flooded the subway system. And it was not even a very big storm that did that. And some people think that storm surges, even before sea level rise goes to catastrophic levels, storm surges could paralyze the electrical, the plumbing system, and the infrastructure of a city. What are your thoughts?
Yeah, storm surge is definitely the most dangerous short-term effect of this. Look, we saw what storm surge did to New Orleans. It wasn't so much the hurricane itself, Katrina, that battered New Orleans. It was the storm surge. And once again, your storm surge comes from a mean sea level. When you keep raising that mean sea level, storm surge goes up, way up, higher. The most endangered creatures are therefore freshwater plants. And what I'm really breaking my heart is trying to think what's going to happen to the Everglades. You've got this enormous freshwater biosystem, which will be so threatened by both storm surge and simply rise in sea level. You cannot live in salt water if you're a freshwater plant. And unfortunately, no saltwater plant, like a mangrove, makes food that humans can eat.
Something to think about. Now let's turn the wheels of time to 2100. What will the great cities of the world look like in 2100?
Well, 2100, there will be 3 feet, only 3 feet if we're lucky, and 5 to 6 feet if we're not lucky. And by lucky, I mean we turn off the lights right now. If it is business as usual, and I suspect it might be because of the increased population numbers, there will be that 3 to 5 foot. The most hard hit will be the wharves. Global transport by ship is still the main means of moving great amounts of food around. CNN projected when I was in Antarctica a few months ago that even a 1 foot rise in sea level will cause shipping terminals and ports and docks and dock heights to have to be modified. And their projection was $1 trillion or more by about 2040 just to spend on the docks. Now, San Francisco Airport, I've landed on that airport over and over and over. A 3 to 5 foot sea level rise in the Bay Area will remove that airport entirely. And so just from the economic points of view, that 3 to 5 foot sea level is going to cause such an enormous financial burden on coastal cities.
Okay, the big question. Will cities have to be abandoned if sea levels continue to rise 3 to 5 feet? And which cities are we talking about?
Well, we've done a lot of projections on this, and I've been talking to some Dutch engineers. The consensus, and again, this is really just consensus of people looking forward, is that civilization and the cities now could probably absorb a 3 foot, 4 foot, even at the worst case scenario, a 5 foot sea level rise and survive. but anything above 5 to 6 feet for a lot of cities is not survivable. New York has high ground. It can simply move back, but Miami cannot. Miami is, I think, the poster child of the type of city that will disappear, as Galveston, Texas will, much of the South Florida cities will, and the Netherlands, of course, is in huge trouble. They already have a significant, I think 30% of the land area is already under sea level, and they spend an appreciable amount of their GNP on dikes every year, dikes and the equivalent of dikes, sometimes big sandbars. When the global economy gets hit hard, it affects everybody, and I think that's what's coming.
Well, what about Boston? Large parts of Boston were reclaimed since the Revolutionary War. If you look at old maps of Boston, large parts of Boston didn't exist until recently. So what's going to happen to Boston?
Yeah, all reclaimed parts of cities are going to go away. The same with my city of Seattle. Our entire bay, Elliott Bay it's called, there's an island. Our major shipping port is an island built up from reclaimed sediment, just as Boston is. And once again, the 3-foot sea level rise allows storm surge, the big storms, to come whipping in and remove a lot of that sediment. You're not going to be able to hold that together. So any city with reclaimed sediment construction, and lots of the airports in Asia, and especially in Japan, they've been building airports out on the water. China's just done it too. All those things will have to be rebuilt somewhere else.
And what about San Francisco, Los Angeles, and especially what's going to happen to New Orleans, where large parts of the city are actually under sea level?
I think New Orleans will have to be abandoned ultimately. It might be a century or two. San Francisco is very interesting. They're very progressive engineers down there, and believe it or not, they have a plan for building a dam right under the Golden Gate Bridge that would save every one of the bay cities. You could hold off sea level rise by building this dam. Otherwise, it's going to be a whole series of smaller dikes and systems and try to save what you can and lose what otherwise. Los Angeles is in an interesting position, too, because the city itself has obviously a lot of high ground, but there are very low-lying areas in Los Angeles that, again, will be inundated to the point that some huge storm comes, salt water is pushed way inland through storm surge, killing off the plants that are there. And then what do you do when you're living in a house that is flooded out by not fresh water, salt water? A saltwater flooding event is way worse than a freshwater flooding event.
And what about London, where we have gigantic underwater devices to help control the water of the Thames River? Are we all going to be like that? Are we all going to be like the little Dutch boy putting our finger in gigantic dikes that we're going to build around our cities? What are we going to do about this?
Well, the British have thought a lot about sea level rise, too, and they are planning on contingencies for up to 5 feet. And you just really hit it. They're thinking about what sort of engineering do we have to do to save our cities. Historic cities, such as London and any of the cities in the Mediterranean, will do everything and anything to try to keep their shorelines as they are now. But it really all depends on where we can stop this. Look, if we melt every single glacier on the planet, we have a sea level rise of over 200 feet. That was the case less than 17,000 years ago. We know from the deep past that when carbon dioxide has been 1,000 parts per million, there is no ice sheet. And we're at 380, 390 and climbing. It's just, that to me is the spookiest aspect of it all.
Okay, and what's going to happen to growing areas of the world, like California has the San Joaquin Valley, other places have gigantic growing areas. What happens when salt water begins to intrude upon these growing areas?
Agriculture becomes very dicey. Obviously, the San Joaquin Valley is enormously threatened. 20 years ago, it was already recognized that there's salt creeping in. Once again, if sea level goes up a little, salt goes sideways a whole lot. And any sort of salt within your soil reduces productivity and ends to the point that you can no longer grow crop plants. So this San Joaquin Valley itself is endangered. The northern Sacramento Valley is in trouble. And as I mentioned earlier, every delta on the planet and all that rice from Southeast Asia, those are the targeted places that we should worry about most agriculturally.
Okay, and well, let's be very specific. I live in Manhattan. Manhattan is a little bit above sea level. The place where I am is about, 15, 20 feet above sea level. However, certain parts of Manhattan are very close to sea level. Wall Street, for example. So what is Manhattan going to look like, and are we going to have to use a system of dikes to prevent the flooding of Manhattan?
Yeah, there will have to be some sort of mitigation going on in Manhattan, if not for the sea level rise itself, certainly for the storm surge. Again, a small level storm surge is the takeoff point for, a small level of sea level rise is the takeoff point for storm surge. And in my book, I actually did some elevation counts for various areas and various streets in New York. And not off the top of my head, I actually projected winners and losers in New York City and its boroughs.
Okay, and let's talk about Venice. Engineers have seriously looked at the problem of Venice. San Marco Plaza, the famous plaza, is actually underwater for parts of the year. So what have we learned by trying to do these gigantic engineering projects like for Venice?
Well, Venice is really interesting because they're putting out into the bay that Venice faces what is sort of a non-traditional dike in a way. It's not like a single wall that the little Dutch boy can put his finger in. But what is interesting and sort of alarming for Venice is also in Holland. It's not just the sea level rise, but it's the fact that the rivers behind yourself. These big cities were often built upon rivers. And because we've got global warming, it's not snowing in many of the mountains. In the Alps and in the Sierra, for instance, snow level is higher. And so instead of snowing in the winter, it rains. And these rivers rise at times they never used to rise before. So Venice is fighting a two-front war, as is many of the Dutch cities. You have to worry about the river that runs through you as much as the sea coming at you. And as any of the military geniuses said, two-front wars are often hard to win.
So Venice may have to be abandoned at some point, you figure?
I would suspect, yes.
Okay, and your book goes beyond 2100, goes to 2300 and beyond. So what is the coastline of the world going to look like now beyond 2100? If I have a map of the world, what will school children see? The North Pole gone? The coastline changing? What will the Earth look like beyond 2100?
Well, it really boils down to some simple geology. Continents, as we know, move around. In the direction that they move, like North America's west coast, there are high mountains generally. But trailing edges, we call them passive edges, don't have mountains, or they have mountains that eroded away, as our east coast does. So you've got the enormous Gulf Plain, you've got the enormous East Coast Plain in front of the Appalachians. There'll be inroads all through that. The problem that we see is that most estimates and models think up to 2100 and stop. But at 2100, if it's business as usual, say we kept it at 3 feet, it doesn't stop there. It keeps going in accelerated fashion. So if you have 3 to 5 feet by 2100, it's not going to mean that you would have twice that by 2200. You could have 3 times that high. The acceleration is the most ominous aspect of this business.
So let's just do a computer program. Assume that at some point we stop greenhouse gases into the future, but we just let the computer program run. What will the world look like? Will all the great cities be underwater by then, by 2200, 2300?
No, ice sheets in Antarctica, they are thinning, and they're thinning in both Greenland and Antarctica. A great deal of that water is going in, but the ice sheets are enormously thick in both places. Greenland is far more endangered than Antarctica is. You're not going to see a wholesale flooding of the cities by 2200 or even 2300, which possibly gives us time, but you're certainly going to see effects where the cities that will have to be abandoned, I think that will already be taking place. We just have to maintain these ice sheets with as much integrity as we can, and that means slowing the global warming temperatures, which seem to be inexorable. Look, we just went through this huge recession. We should have had 2 or 3 years because of the economic downturn when emissions could have been or should have been reduced. They weren't. I mean, they're right up at the IPCC's maximum emission prediction. We're not lowering emissions. We're increasing emissions.
Okay, now let's go into the past. You can do that because we can drill into the ice cap and get ice cores from thousands of years ago. 10,000 years ago, we had the Ice Age. It was very cold 10,000 years and beyond that. So how far back in time do you have to go to find a time similar to what we're going to be experiencing in the future? And what did the world look like at that time?
Well, the conventional answer is that if we get up to 1,000 parts per million, which would happen in 2 centuries from now, if we have some sort of control on emissions, a lot of us think that 1,000 parts per million would be a lot sooner than that. But you're going all the way back to a time called the Eocene. And the Eocene was a very interesting time when we had crocodiles up on the North Pole. We had palm trees in Seattle. We just had this wonderfully tropical climate. The bad news is that sea level was 240 feet higher than it is now because there was no ice. There were no ice sheets at all on the planet.
Well, I'm afraid that's it for Exploration. Once again, our special guest today was Professor Peter Ward. The book is Flooded Earth. And you are listening to Exploration with Professor Michio Kaku. So once again, stay tuned every week to Exploration when we discuss the impact of science on society. Good day.